17. How do you like
I do
me?
need to use a little girl's one. Isn't that a movie, 17?
It's a song.
There's so many songs about being 17.
It's like the age of innocence before you.
Is that
And 17.
Last Dance?
That's Dancing Queen. They don't say 17 in there, do they?
Yeah, they do.
Oh, do they?
Doug is the
You're telling a story, Aaliyah. You too? Did y'all think it was hard? So I know that we run through. Let me work a few. I know. Okay.
It got ran through.
Let me give you, before I start, you are doing these, you probably have this right in front of you, right? That's what I would do. The derivative of natural log is 1 over x dx, right? So if I need the derivative of the natural log of x is 1 over x dx. Keep in mind that it's whatever this is what goes in place of the x here. So don't get, right? Just like with the signs and everything else, because I could have chain rule that comes into play. So dy dx is going to be 1 over, and I might even change this to this so you see it a little bit easier. Sure, because the derivative of natural log is 1 over x.
Would you not put that at the top?
I would, but right now I want everybody to see where it's coming from, so I didn't. I'll go back and change it in just a minute. 1 over whatever you're taking the log of, but now I need to do the chain rule. So now I have to do dx. What's the derivative of what was in parentheses here? Negative 1 times x to the negative 2. You've got to include that dx. Whatever's in the bottom here, you have to do the derivative of. Okay? If it's just x, the derivative is 1. But if it's a function, then it has I got to chain rule it, right? So this actually becomes, well, this moves up. So I have x times, right.
All right, hold on. You got negative 1 over. All right, that makes sense. You just simplify.
What? So now I've got negative x over x squared, which simplifies how? I'm trying to take it really slow.
Negative x to a negative 1.
Which is negative 1 over x, or negative x to the negative 1, correct? Because since the x is in the denominator, I'm assuming is y, and you can't take the log of a negative number. Because initially, in this one, it couldn't be 0 because then x would be undefined. But it's got to stay positive so that you don't have to worry about that, because that will be given, if this is a multiple choice question, that will be given to you in multiple choice form. I've never seen you have to restrict a domain like that on an FIQ in that situation, but that's why. You can't take the log of a negative number, and if you think about it, the log of negative, I don't know, just negative 1, what can you raise e to get a negative number? Well, there's nothing you'll ever be able to raise e to get a negative number. It's an irrational number, yeah.
Well, it's never 0 divided by 0.
That's not true. With the exception of 0. What? Somebody had their hand up.
I did.
Yes. So what I did here, x to the negative 1 can move up and become positive. negative 1, this becomes positive and moves down to the bottom, and it's still negative. Anytime you move it, no matter if you move to the top or the bottom, it changes signs. Yeah, the exponent, not the value of the number, the exponent.
So you move the x to the top, made it, then you power
Positive.
So basically, you're just
Say that again?
manipulating x. So
Yes.
x to the first power times negative 1 over x. Then she just simplified and crossed out x.
Yeah, x, this is like everyone, it's top comes top and bottom comes bottom. So the derivative of log x is 1 over x dx. I have to chain rule it. Or maybe, so think of it as log of blah. It's going to be 1 over blah, but then you have to do the derivative of blah for the chain rule. Does that make more sense instead of it being that just the x there?
Why can't you just take negative x to the negative second power over 1 from, like, why can't you get the answer from there? Why do you have to split it up?
You could have. So I could have had, if I move this up to know that that's x times negative x to the negative 2, I could think about properties of exponents and know that I add those together. And that would be negative x to the negative 1. It still brings me back here.
Okay, so how do you know when to stop?
What do you mean?
Like, how do you know when you want to finish with that?
Well, so this would be an acceptable way to leave it. This would be an acceptable way to leave it. I would say once it's simplified, and you can't simplify it any further. But, I mean, theoretically, these are both simplified. So either one, stop it, Van, go sit down. Does that make sense? You can't simplify it anymore. But there's no rule. Pretty math, we don't leave negative exponents most of the time, but there's not a rule that says you can't.
Well, I'm still confused why you wrote x to the negative 1 in the bottom. Wouldn't it be at the top?
I didn't write x to the negative 1 at the bottom.
And
Because the derivative, the log of whatever, is equal to 1 over the whatever times the derivative of whatever. The whatever this time is 1 over x. Does that make sense? That whole blah or that whole whatever is 1 over x. I do not, but it should be on her desk if you don't know. Thank you. Does that make sense? The point is, it doesn't matter what's in parentheses. Give me another one that's a log. 18.
You know what they say about being 18? It means that
If I do the derivative here, 1 over 10 over x, or 10x negative 1, I could write it that way if I wanted to, times,
oh. Now,
yes, it means take whatever's in parentheses and put it all over under 1.
Now,
That's yes. And
now I
then
understand.
do the derivative of that,
So you could do 10x, yeah, you could do 10x to the negative 1 on the bottom.
which would be, you could. But if I take the derivative of it, it's easier to write it that way, so I can take the derivative. So it's negative 10x negative 2. There's my dx. That's my chain rule coming into play there. Okay? So now this becomes,
That's just your derivative.
this
of
is
10 over
x
x,
over 10
right?
times, what?
That's your derivative of 10 over x.
Yes.
Or you could just like cross out negative.
1 over 10 over x is x over 10. Instead of dividing by, yeah, you flip it. This x and one of these x's, I end up with negative 1 over x.
Wait, hold on. How did you get x over 10? It's 1 over 10 over x.
Do you agree that that's the same thing?
Yes. Yeah.
Do you agree that you can move that up because of the negative exponent?
Then it'll become x squared negative 2. Right?
No.
And then you just change the positive. So x squared.
All right, give me another question about your homework. 23.
You know, I'm majoring in
Dylan. All right, how do you find the derivative of a log? The derivative of log base a of x is 1 over x. Oops. And then dx, exactly, sorry. Remember, dx, that's the derivative of this that follows. So that's going to be the derivative of this chunk. Your base should be about just a constant number.
A is just like that.
Not today.
Well, Lizzie, if you were as smart as Miss McGee and I, then yes. You do that all the time.
Wait, you just said Miss McGee and I. Yeah. Miss McGee. You were smart as I? I'm not joking about how grammatically correct this sentence is. I'm talking about how
It's not.
What are you talking about? It's Miss McGee and I.
So that's just like a real. What, hey, Miss McGee, what do you mean by DX?
Okay, dx is where we take, that's my chain rule coming in. It's the derivative of whatever this is.
And we're just supposed to memorize onto that.
Yes. Remember that little thing I told you that happened to me in college? This moment was, I don't know, but yeah, I feel bad about it. I'm telling you my mistakes from my past. That was, no, I'm telling you no. Okay. All right, so let's find dy dx. No, please don't do that. Dy dx is, all right, 1 over x times 1 over the natural log of 2. Now do the derivative of the bottom. What's the derivative of x to the negative 1?
Well, it's negative x to the by the way, Mr. Freeman is your proctor. You don't have to look at this calculator. Man, why would you even say
This is x. Now get me fired. Y'all do not do anything like that.
We had this problem in Chem last year too. We always said some out of pocket things.
Oh my gosh. All right. I'm going to make this negative 1 over x squared. One of the x's, yes. So I end up with negative 1 over x times log 2. Because they're top and bottom, and because this little sign right here is not a plus, right? Properties of exponents. If it's a negative exponent, you can move it and make it positive.
What if I put that x after the
If it's positive,
Doesn't matter.
If it's positive,
Just, I would make sure if you put it after that you don't write it like this, that it's clear that this is, yeah. Or maybe even like this, so you know. All right. What else? 24. 7? OMG.
I just thought it was I'm sure that's chapter 3.
I did it, but then like we have to
You don't even have to solve the natural log.
That's actually more accepted than giving a decimal approximation. It's an exact answer. I think that if you got stumped on this one, you didn't think through this one. Okay, this is a constant. That's just a value. That's like having 5x or 10x or 25x. So what's the derivative?
Well, then it's c squared. Minus the x.
This is just some number. It represents a number. It's like if I had pi x or if I had 5x.
Don't you gotta do the power rule?
Yeah.
Don't you gotta do the power rule?
No. That's the constant, man. If
What's
power,
the derivative of
it's
e to the x?
It's e to the x.
E to the x.
That's your derivative.
What happens to that other x?
But this is e squared x. Well, if you take the derivative of 5x, what's the derivative? 5. If you take the derivative of pi x, what's the derivative? So if you take the derivative of e squared x, what's the derivative?
Hey, so the reason you don't do power rules is because it's not on the x, right?
Correct. The squared is not on the x. Don't multiply that around to fly on your desk. All right. What else?
I don't know. This makes me uncomfortable.
Fine. What else? What else? 24. All right, 24. Y equals 1 over log base 2 of x. I think in order to do this problem that maybe I will change this to this.
Couldn't you just do power rule to change it?
That's exactly what. Look at you, Van.
Look at you. Yay. You're still ugly. All right.
No. Ignore him. Sit down. Ignore him. Stop calling him ugly.
He said I didn't look good.
Van, when I do this power rule, tell me what to do first. Mm-hmm. That's exactly right. She's not, though. This was a hard one. And you said it before everybody else. You said, oh, we can just power rule the channel.
All right.
What is that, Miss McGee? What does that x turn into?
The x stays. Okay. I haven't finished the problem. I can simplify it a little bit. Oh. But derivative of x is. So if you want to, Van.
Wait, so where
All right. Where'd I get what to?
The 1 over x and the 1
All right. So if you've got log base a of x, the derivative here would be 1 over x times 1 over the natural log of a dx.
And dx is just like, yeah.
So I could write this as negative 1 over log base 2 of x squared times 1 over x times 1 over natural log of 2. And just smush them all together.
You like that?
Mm-hmm.
Yeah, that's like it needs to be washed.
The terminator is at second block.
I thought you were going to.
Oh my
Why would you throw it? Why would you do that? Why would you do that?
All right.
Yeah, if he's not going with $10 drink, you give me $10 right here.
Maybe stop. You spend like $70.
$10 drink. You say that like it's my fault if he's not going.
All right. Other questions about your homework?
These aren't that bad.
They're literally plug in if you reference this. I am going to give you 2 minutes to get out. I know.
Are we not using this today?
No, you won't use that day. Put your name in it though. Don't lose it. And remember, don't tell everybody else that I got those for y'all.
You said on 143.
133. But if there's something you're struggling with or something we get to that you're not sure, two, you can look. I like this book because if you look at the index of it, it also by topic tells you what's BC and what's not. So you see why we're not covering
I'm
some
gonna
stuff.
tell like all the other teachers that you bought it with.
Don't lie, Dylan. Okay.
Let me get out.
Christmas time, let's get an elf on the shelf.
I have like 3.
No, I'll use mine anyway.
My elf moved one year when I was like 8 o'clock.
Ren.
My mom had literally like dog ate my elf.
I found out that Santa Claus wasn't real when
Oh, I forgot y'all's Halloween trees today. They're sitting on my table. I'll bring them tomorrow. It's just
My
little.
mom moved my elf
It
for like
scared me so
years.
I tried to do it.
Like I don't know why she stopped, and like she still like makes us say like, oh thank you Santa, even though it's like August. She like still writes like from Santa on all the gifts.
All right.
I found out Santa Claus wasn't real when I saw that there was a please recycle tag on the back of the elf.
I don't even know
When I was like 12 or whatever.
I don't remember when I found out Santa wasn't real.
Before I go through this, let me run through really quickly the prop. Y'all asked me this yesterday and I forgot, so let me do it first. Before we do that, those properties of logs that you may have forgotten. Right. So any log that I have that has an exponent on it this way, I can change it to be written. I can go from left to right or right to left, depending on whatever benefits me the most. But I can bring this around to the front and multiply this whole log expression by x. Bless you. If I am multiplying two things together that are both applied to this log, I can split this apart because logs are exponents, and if you think about it, when you're multiplying with the same base, what do you do with the exponent?
So you're saying
You add
like
them, so you can
log
split it up.
Log base x, log base b is x times log base b.
Plus, not times. You said times. Mhm. Yeah, we did an algebra too. Yeah.
That was a long time ago.
Exactly like this. Yeah.
Oh,
I still have my notebook in it.
that makes me happy. My AP Cal notebook from high school was the only notebook that I kept all through college, and I actually referenced it. I referenced it all through college, and I referenced it whenever I went back because I didn't start teaching right away. That's what I studied before I went in and took the practice. High school AP Calculus notebook, looked over it, and then went in and took the practice and passed it.
I would like bring my algebra to pre-cal because like for like the exponent.
Yeah.
I know exactly what it was.
Right. That's awesome, y'all.
I write because I know.
That was like 2 years ago.
All right. There's your log properties you asked me to review. We will be referencing them as we go through things. Now, here's logarithmic differentiation. It's not that you have to ever do logarithmic differentiation. It's that if you know this little trick, it will make differentiation easier for you as you go through. So in other words, Tuesday. All right, if I look at this one and I want to find dy dx.
Why'd you lose focus?
If I want to find dy dx, this is going to be kind of hard, right? Because I mean, power rule, what in the world do you do, right? So what logarithmic differentiation does is it allows us to write it a little bit different. So what we do is we take the log of both sides. Mm-hmm. Natural log. That's generally what we do is natural log. And then we'll use log properties to kind of rewrite it before taking the derivative. And it'll make, because honestly here, I mean, seriously, what are you going to do? Bring this around front? I mean, there's not really, I don't know how to derive that, right? So here's what I'm going to do. I'm going to say, okay, well, if I do the natural log of both sides,
Where it's log A of
Oh, yeah, the first one.
Oh, so you multiply everything.
we haven't, in this case, we take the natural log of both sides. We haven't been doing that. We've been taking the derivative first and then working from there. How does this make it any better? That doesn't cancel. What happens if you have an exponent on a log?
It goes out in front.
It goes out in front. So really this is log y. Yeah, here's my original equation, which is what?
Natural log x squared.
Oh, so now let's think about this. Now if I try to take the derivative, it's the exponent. I'm going to use those three properties to rewrite it to make my life a little easier as I try to find the derivative.
Wait, then you're gonna have to divide by natural log from the left side, right? You want to know what y is. Oh, you got to chain rule too.
Do what?
Take the natural log of both sides.
You did that already.
I
did,
know, like,
yeah.
I'm saying, what?
You do it so that it's in a form that I can do the derivative. Yeah. So now.
You can do that for anything, just take the natural log.
Sure, you can do anything to both sides of the equation. Okay. Now this is tough, y'all. This is tough. I have to do implicit differentiation now. Okay. Then.
I like it.
All right.
All right, let's do it.
What is the derivative of natural log of y?
It'd be
1 over y
dy dx.
dy dx. Because I'm taking the derivative with respect to x. It equals, now I'm going to do, what's your rule for taking the derivative of log? The derivative of log of a is 1 over a, and then whatever. Oh, I shouldn't use a.
Can you all stop acting like these for like 5 minutes? Like every transaction, like
dx.
All right,
Ln x.
Do what?
probably start the timer for 5 minutes.
why you going to do that?
What?
All right, guys, y'all need, this is hard. I'm telling y'all this is hard. Y'all need to focus. Yes.
Oh, wait, never mind.
All right, so I'm deriving both sides, okay?
All right.
So now on the right side, I'm going to do power rule, 2 times log of x to the first.
You don't have to write that.
We don't have to write that, but just to show you. And now chain rule. What's the derivative of log x?
Oh, 1 over x. Yes.
Okay, so that's not it because, yes, I'm solving for dy dx. My whole goal in the beginning was to find dy dx multiplied by y. But remember when we did implicit differentiation, we can't have a y in our answer. We don't want dy dx equals blah, 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 y, blah, 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 blah. We just want x's in that answer. So this is gone from this side. I have dy dx equals, And I'm just going to put this in one fraction. 2 log x over x times y. Well, now the question is, well, that's all well and good, but what is y?
Well, y does equal x log of x.
Y equals log x. No, what is it?
X to the log of x.
There we go. So I'm just going to replace it. And I'm going to leave it just like
Well,
that.
that's not a derivative, though.
It doesn't have to be the derivatives. This is just y.
Wait, so we're not finding, wait, I thought we are finding.
No, we did find the derivative.
We did. We found dy dx.
Find the derivative of this.
So logarithmic differentiation is implicit differentiation.
It's using implicit differentiation.
Or, you could do, Mr. G, you could have wrote log of x, natural log of x squared. Like, you got that.
We did. That's not y, though. That's what the log of y equals. This, by the way, was number 53 from your homework.
Okay, so then
Let's do another one.
What now?
That's it. We found, the goal was to find dy dx, and I found dy dx. I just had to use logarithmic differentiation and implicit differentiation to find it.
Find dy dx, I'm not going to simplify that equation.
That's fine. You can. A fat equation.
Maybe I do.
You said this was 57?
Yes. Let's do, let me give you one to do by yourself before I really crank it up. Yeah, this will be an easy one.
I think it's the bottom.
Sorry.
Which part?
So when I'm stuck on how I can find the derivative, because my derivative rules are not working, maybe I have a variable in the base and the exponent. I can take the log of both sides first.
You multiply natural log by everything in the beginning.
No, I'm talking
About this.
when you said, yeah, y.
Because I went,
Of the original equation.
the original equation was y equals x to the log
And we
x.
wanted to do that every time.
I want to put, I don't want any y's in my answer. I only want x's. Okay.
You just multiply natural log by everything. So that we get, that's just what we did. So then she could power rule when we did that. You can't bring natural log x in front of x.
That's the log property. You have log base b of a to the x. You can rewrite that as x times log base b of a. Whatever's in the exponent comes around to the front to be multiplied. So about this one around front.
Oh, no, sorry, we didn't do the power rule. We did that. After our AP exam, I only got lunch.
That was so far.
I'm thinking about food right now.
So what are you not thinking about?
I'm always thinking about how you can get that ugly face. The AP exam is not that far away. It's only like 5 minutes. That thing's only like 2 years away.
Look, don't believe me.
For what?
I already read all this.
That's cool and all, but I didn't ask.
This chapter.
Didn't ask at all.
Who else did it? Parents did?
For what?
Unit shift. We had
Yep. Sorry.
I feel like the problem is.
Find dy dx.
The problem is I don't always know.
All right, let's do it. Let's do it. What, do you know what question this is?
This is just a random example. We'll do another homework. The homework ones are a little bit harder than this. Find dy dx. That's okay.
Alright, I know what you're doing.
Would I still want to take the natural log? I know what it means, but it doesn't want to log.
You're right. Can you make that y equals x squared?
No.
Like you would for natural log?
Y equals x squared.
Well, he's saying use the power.
Or, if, no, I'm not. What if it was xy equals x squared?
Well, if it was x squared, then you can just do power rule. You can't do power rule here because the base and the exponent are both the variable.
Is this one on our homework?
No, this one's not on homework. This is a little bit easier one. If the base and the exponent are both the variable, you can't do the power rule like normal like that. You can't take the chain rule into play there.
So then I don't put.
Use logarithmic differentiation.
That's what I'm saying.
Oh, yeah,
If
I'm
you put an
sorry.
x in front of the y, and then bring the x down.
Just do it on your paper.
Would
Right.
you use it like the natural log? Or do you not use it in the original?
You do. It wasn't in the original before. You're going to do it to both sides.
Oh, so you can multiply everything.
Listen,
That's what it was in the beginning.
Take the natural log of everything.
Yeah.
So make it natural log y.
And you do the power rule.
So you get natural log of y equals natural log of x squared, right? Yes. Because you would multiply them together when you bring the exponent down.
No. Listen, it would be x times the natural log of x.
Why would you not do natural log on the top on the exponent? There's no powers to that.
You're right.
So you just bring it down. Well, then what was the point of putting natural log in?
What was the point? Can you take the derivative now? Now you can use product rule to take the derivative. That's what she was saying. What's the derivative of log y? Derivative of the first times the second plus the first times derivative of the second.
Ms. McGee, can I ask you if this is the correct answer?
Yeah.
X to the natural log of x times x.
Nine.
What's the answer?
No. X to the x element.
Yes.
That's what.
All right, this becomes 1. So I really have 1 over y dy dx equals natural log of x. Then I got to get,
Wait, did you not multiply both sides?
I'm fixing to. I don't want to leave it as y though. Y is x to the x, and I have natural log of x.
Wait, so where it says ln y equals x times ln x, what did you do? I get what you did on the left, but what did you do on the right? Did the chain rule? Wait.
On the which part,
You
Van?
see where it says ln y equals x times ln x? I get you take the derivative on the left, but for the right side, you do
Product rule. Yeah.
Okay, so that.
This, for right now, you'll do this when it says use logarithmic differentiation to solve.
Okay, right here, on that first one we did, we put log of x in front of everything.
Oh my!
But on this one, we didn't.
Because it was,
On this one, we just put it in front of the x and not the
okay, whatever the exponent is what comes around and multiplies. Whatever the exponent is what comes around and
I know,
multiplies.
but if you put natural log in front of this x and this y, then you would then put it on this too. You gotta put it on everything, right?
No, well, you just do it to this side. So think about it being You just log both sides.
Well, then why, when it's on the exponent, do you have to bring it down?
Well, that's that property. That's that property of exponents that says if you're taking the log and you have an exponent, you come around front and multiply. All right, y'all ready for a toughie? That one wasn't. You have. Okay. 49 through 61. 193. 193 and 194. $49 through 61. All right. This one is number 52. And the directions say use logarithmic differentiation. Actually, let's do 51.
I just don't like
Well, you just want that whole thing to the one half and do a little bit of power rule.
Use logarithmic differentiation.
No,
No, bro. Part of mine.
This is a tough concept. We started out easy, but this is where it really comes into.
because you're like 5 rooms.
Wouldn't life be great if we could always
I would advise you to go ahead and change that fifth root to a 1/5 power. Your powers are going to come into play here. Once you apply all the logarithmic properties here, it's going to make your life easy when you go to take the derivative. Don't even do that. Put this whole thing to the 1/5 and let's natural log both sides as is. So I have log y equals the log of x minus 3 to the 4, x squared plus 1, 2x plus 5 cubed. There. All right, let's bring this exponent around front first. Yes. I'm gonna run through a couple steps here. Slowly. Keep going. I'm just bringing this 1/5 exponent around the front. What I'm going to do first is I'm going to get this expanded as much as I can before I do any type of derivative. Don't think derivatives right now. Right now, think algebra 2. I'm just going to expand this log as far as I can first. No. I haven't done the power rules.
That was the property.
If I'm dividing, I can split that up with subtraction. So I'm going to say x minus 3 to the 4, x squared plus 1 minus the log of 2x plus 5 to the third. Because if I'm adding and subtracting, I can take the derivatives individually. Right now, if I tried to derive this and chain rule it, I would be in some nasty, nasty territory. I could, but oh my gosh. Not yet. We're not even going to use quotient rule. I can break it down even further because this is multiplied. I can split that up with addition.
Yes.
So now I'm log y equals 1/5. Remember that 1/5 is going to everybody. The log of x minus 3 to the 4th plus the log of x squared plus 1 minus, no. Oh, sorry. Now I can bring all the exponents around. That's exactly right. So I have the log of y for log x minus 3 plus log x squared plus 1 minus 3 log 2x plus 5. Can't take, well, then you'd be backwards. You'd be going backwards if you did that. So I think what I will do now is go ahead and take the derivative. I could split this up yet again, but really, why? Right? I'm going to, at this point, actually, I would have to put it together with, at this point, I'm ready to derive, okay? I can't, because these are hooked together here, I can't really do anything else with them.
Can you combine the coefficients in the front?
Combine what coefficients?
Chain rule.
You don't even have to do chain rule. Now, if it helps you to see it, if you want to take this 1/5 to all these pieces, you can. So that it's log y equals 4/5 log x minus 3 plus 1/5 x squared plus 1 minus 3/5. Oops, that's a log there, sorry. I just took that 1/5 through. You don't have to. It kind of helps you see, bless you, where things are coming from. Now let's derive both sides. One over y dx equals, I've got 4/5 times, what's the derivative of the log of x minus 3?
1 over x.
Yes, yes. I just didn't want anybody to say where'd that come from, so I wanted to make sure I showed. And the derivative of x there is just 1, so I don't have a chain rule to worry about. So write it if that helps you, yeah.
Wait, how do you know?
Because the derivative of x minus 3 is 1.
Oh, yeah.
Okay. Plus 1/5
You will on this one.
times, you will on this one, you're exactly right.
Wait, hold on. Why did we do times 1 at the end?
That's the chain rule. The derivative of x minus 3 is 1. The derivative of x squared plus 1 is 2x. Two is my chain there. Okay, so that's the first bit of calculus we've done with this problem, right? Is the derivative. We did log properties. Now we're fixing to simplify the fractions. All right, so we have 1 over y dy dx equals, I'm just going to make these into 3 fractions just so you see what's going on. I've got 4 over 5x minus 3 plus 2x over 5 x squared plus 1 minus 6, 5, 2x plus 5. I am almost there. But, yep. I'm just going to throw a parenthesis and times it by y. Yeah. But whatever, just write it and leave it. You don't have to do anything with it. This is your x. Remember, it's the log of blah is 1 over blah times the derivative of blah. Yes.
What was y? Oh, it's that stupid.
It's a lot to write, but at the end of the day, you don't have to do anything with it. You're just...
Do you have to distribute the,
No.
more work?
Yeah. I wouldn't do anything else with this. When I got to this point, I would leave it. What was this? The 5th root of... And there's your answer.
Are we gonna have like long problems with that on here?
That was on.
That was on your homework. You have 2 like this. This is one of them. The other one's not quite this long. Okay.
Hold on.
You also have a few word problems. I know you're going to struggle with them. Try as best you can. We will go over them tomorrow. I had all intentions of doing one more with you. I think y'all's brains are fried.
It's just a fan wasn't so like.
This is just, I feel like this is just a long process. It's not a hard if you know your log properties, it's a piece of cake. But everybody always struggles with log properties. So
We don't really learn that. We don't focus on. Yeah.
You know, like the